So today I would like to talk about the kinematics of ionized gas. And I believe that yesterday, the Henry's talk is a really good introduction of this talk. So the ionized gas and stars actually have different responses to the gravitational and the non-gravitational processes. So that is, the ionized gas is very sensitive to the non-gravitational processes such as mergers, turbulence, and the stellar and the star formation or the AGN feedbacks. Whereas the stellar kinematics is much less sensitive to such processes, and therefore they can be served as a reference point to study the impact of the non-gravitational processes on the ionized gas. So here I'm studying the velocity dispersion. I'm comparing the velocity dispersion of gas and stars. So here, so when I'm comparing those two, so the expectation here is that the gas, ionized gas, is maybe dynamically colder than the stars. And the expectation is also there that the stellar velocity dispersion would be much, much higher than the gas velocity dispersion. And this expectation is true for many emission line galaxies, and especially when there are star formation. However, not the stellar, the gas velocity dispersion is not always smaller than the stellar velocity dispersion. And the difference between two, the delta sigma, this delta sigma does seem to relate to the galaxy properties. So here I want you to explore which galaxy parameter is directly related to the delta sigma, the difference between the stellar and the gas velocity dispersion, and also what is the physical processes behind that. So I have explored these 9 galaxy parameters, which describes the structures of the galaxies and also the populations of the galaxies. And also I have used the CAGN parameter, which is also related to the population of the galaxies. And this has been defined using the initial line, the diagnostic diagram. So here the CAGN has been measured from as the departure from this dashed line here, separating the star formation and AGN. And also I introduced the 2 other parameters, which is related to the observational limit of the Sree spectroscopy, so-called beam smearing. So here, first, I would like to show the correlation between the delta sigma and these various galaxy parameters. So as you can see that the delta sigma has correlation with all these 9 parameters. And the difference is only just a matter of magnitude. And here, I have an assumption that there might be a primary parameter. That primary parameter has a physically connected to the delta sigma. And there are all other parameters is not having the all other parameters do not have the correlation to the directly correlation to the delta sigma, but showing the secondary correlation based on the correlation between these parameters and the primary parameter. So there is my assumption, and to test this, I did this analysis. So this is an example. So first, I assume that there would be just one single parameter the primary parameter that has physically connected to the delta sigma, and also that explains all other secondary correlations. There was the assumption here. And this is an example when I assume the CAGN parameter as the primary parameter here. So the thing what I did here is, okay, so I tried to remove the correlation between the delta sigma and the CAGN. And then I explored whether there are residual correlations from the other parameters. So as you can see, there is no correlation between the delta sigma and the CAGN after the correction, but still I find the residual correlation from here and here and here. So that means the CAGN is not the primary parameter that explains all other correlations. So I repeated this analysis by changing the primary parameter. And then the conclusion here is, there is no such magic parameter that explains all other correlations. So my next step is assuming that, okay, then there might be two primary parameters independently contribute to the delta sigma and also explain all other secondary correlations. So this is an example when I chose this two parameter as the secondary, as the primary parameters. And here I try to remove the correlation between the sigma and these two parameters simultaneously. And then I explored whether there are residual correlations from other parameters. So here, this example, yes. So for this example, you can see that still there is a residual correlation with CIGN parameter. So that means these two parameters, the combination of these two parameters cannot explain all other secondary parameters. So I also repeated this analysis, choosing the many different combination of two parameters. And the conclusion here is again, there are no such two combination of two parameters that explain everything. So my conclusion of this analysis is, okay, we need all the three parameters to explain all the correlations with delta sigma and all other parameters. And here I only show the 9 parameters, but actually I have explored more than 20 galaxy parameters. And the combination of the 3 parameters actually explain all the correlations with the delta sigma and these more than 20 galaxy parameters. So, okay, so it seems this 3 parameters is indeed related to the delta sigma. Then what are those three parameters stand for? So first, I would like to discuss the impact of beam smearing. So beam smearing is sort of basically the impact of the scene. And this beam smearing is actually specially smooths the velocity dispersion and the velocity gradients. That the thing is, okay, we want to measure the velocity gradient, line of sight velocity gradient. But within the scene, we cannot differentiate the line of sight velocity gradient, line of sight velocity dispersion and the velocity difference within the scene. So definitely, if there is a beam smearing effect, the beam smearing artificially inflates the measure of velocity dispersion. And this beam smearing is definitely related to the size of the scene and the velocity gradient within the scene. So that's why we can find the pretty tight correlation between the delta sigma and these two parameters. But even considering the impact of the scene, we still find the correlation between the delta sigma and the CAGN. And as I explained, as I introduced, the CAGN is related to the contribution of the AGN-like emission when there is emission lines. So, and also this parameter is related to the shock or the outflow fractions. So as you can imagine that, so if there is the outflows or the shock, then it is very effective way to inflate the gas velocity dispersion. And especially here, I expect that the Asian feedback, that means Asian-driven outflows may inflate the gas velocity dispersion. And this Asian feedback actually generates the relation between the delta sigma and the CAGN. And another explanation another explanation for the relation between the delta sigma and the CAGN is a difference in the emission line regions according to the power sources. So for example, the actively star-forming galaxies, their hitched regions, the emission line region of the actively star-forming galaxies are spread over the disk component, which is dynamically colder than the stellar parts. Whereas the Asians, they are supposed to emit the more centrally concentrated emission lines. And the center of the galaxies and the central part of the galaxy where they emit the emission line, Asian-like emission is dynamically very hot compared to the stellar parts, full stellar parts. So the difference between difference in the emission line regions according to the power sources also contribute to the relation between the delta sigma and the CAGN. So to summarize, I found the correlation between these 3 parameters and the difference between the gas and the stellar velocity dispersions. And to explain this, I introduced the beam smearing effect, and I would like to emphasize actually that beam smearing should be seriously considered even for large inner galaxies and even at low redshift, especially when you discuss the gas kinematics. And also to explain the delta sigma and the CAGN relation, I think the Asian-driven outflow, so Asian feedback is doing something there. And also the centrally concentrated the emission line from Asian may also contribute to the relation between the delta sigma and the CH. So yeah, that's it.
Thank you.